I mean, there are a couple of people got 25 out of 25. I mean, it is pretty good. Nobody, as far as I remember, let's take a look. Yeah, nobody got below 15. Nobody got below 50. That's very good. Yeah. So let me mention this because this is important. This is final. Don't worry about curves and surfaces. We will talk about all that. Don't worry about your grades so much. Try to do your best. Hello, Mama Sebastian, stop that. Mama Sebastian, stop that, please. A big noise coming from you. Nobody is allowed to make any noise, by the way. Let me mention this because this is important, I think. There was a very big disturbance. It happened long ago in my math 143 class. It turned out to be an outsider. And so I have the authority actually given by the department chair. Any disturbance, any person creating disturbance will be summarily expelled from the class. Okay, math, I will give you two exams. I said that, right? Two exams. Two quizzes, two exams. Okay, exam one, this will be actually five, 7, 12. Good. 5th October, 6th plus 7, yes.
So the exam was.
Just a minute.
Professor, can you push it to 15 instead of 13?
Why? What is the problem with 13?
Another class.
Okay, let this be final. However, I'm going to give you the review next Thursday. Okay? Okay, so that means good. Everybody's saying nice. Okay, that means 13th. Actually, we do meet 13th. I will start with vector spaces. Very, very important. The heart. It is the center of gravity of this course. Yeah, question. When you say two exams, what is your question? Two midterm exams, two midterms, two in-class exams.
So you're not including the final in that? So it's
Let me finish. Plus two quizzes. plus the final exam. And exam 1 will be like this. Exam 1. So 2 p.m. to 3:15 p.m. Okay, now questions. So I deliberately wrote this that I'm going to start with vector spaces on 13th October. Therefore, that means please all of you should come. Remember, this is the most important topic of the course. Most important topic of the course. Everybody should come. Any questions on everything that I have written?
How many questions will be on the exam?
On the final, good question. Not sorry, final. On exam 1, yeah, exam 1 should be, there will be about 7 to 8 questions.
Then can you give us like until 3:30 because
No, 1 hour 15 minutes is more than enough. Actually, we can start a little early because it is one. So we can definitely start a little early. Our class starts at 1:40, so we can start it at 1:50 p.m. So everybody should be here by 1:40 so that I can send you the exams by 1:45. And immediately.
okay, that sounds good. 150 is good.
Okay. Any other questions? Will each question have ABCD? What ABCD? What do you mean ABCD? Okay, you want an ABCD? I will give you ABCD. Yes, each question will have A, B, C, D, E, F. How about that?
No.
Okay, now let me go over the quiz things because there are a couple of remarks. Couple of important remarks. Number 1, important remarks, and 3x1 minus x2, and you have to please check this because I really need to mention few things. Now, the point is, if we take the matrix, that just the coefficient matrix, and take its determinant, it turns out -7 -12 -1 1 -4 -6 -14 15 plus 4 no 5 minus 20 0. That's it, you stop there. I got some very funny answers. Some students wrote, they went on to compute the other determinants, A1, A2, A3. No, because remember, Cramer's rule tells you what? By the way, I have written chapters 1 and 2 plus orthogonal matrices. I don't want to forget about that. Okay, Cramer's rule tells you what? X1 will be equal to determinant of A1 upon determinant of A. X2 will be determinant of A2 upon determinant of A. x3 determinant of A3 over determinant of A. Now you see everything is divided by determinant of A. If the determinant of A is 0, then the game is over. That means no solutions. The division by 0 is not defined. Remember, division by 0 is not defined. So, since determinant of A is non-zero is 0, the system doesn't have a solution. System cannot be solved. Cramer's rule doesn't give us a solution. Number 2, some people are making very simple, careless mistakes. I have been very generous. I mean, I just took off 1 point like that. But be very careful. That's what is the determinant of A? 9 minus 16 minus 7 minus 5 minus 3 minus 8 11 plus 5 minus 4 minus 6 minus 10 minus 14 plus 55 minus 50. So 55 minus 64. So that is minus 9. And then you find the matrix of the cofactors. Matrix of cofactors. Remember, I always prefer to write this: plus, minus, plus, minus, plus, minus, plus, minus, plus. So 9 minus 16 minus 7, minus 3 minus 8, minus 11 with a negative sign, minus 4 minus 6 minus 10. Okay, then this goes away, this goes away. 15 minus 20 minus 5 with a negative sign, 5. 6 minus 10 minus 4. 8 minus 10 minus 2, so 2. 20 minus 15, 5. 8 minus 5, 13 with a negative sign. Now, where am I? What happened? This goes away, this goes away. 8 minus 5, 13 with a negative sign. That's right. 6 minus 5, 11. Okay, that is the matrix of cofactors. So what is the adjoint? The transpose of the matrix of cofactors. Minus 7, 11, minus 10. 5, minus 4, 2. 5, minus 3, 13, 11. So the matrix, the A inverse, you can write it in 2 ways. Minus 1 upon 9 times this matrix. You can write it this way. Some students wrote it this way. Or you can simply write 7 upon 9 minus 5 upon 9 minus 5 upon 9 minus 11 upon 9, 4 upon 9, 13 upon 9, 10 upon 9, minus 2 upon 9, minus 11 upon 9. That's the answer for adjoint array. Number 3, I don't know, some people even left it blank. I was very surprised. Solve for x minus 1. 3, 1 minus x is equal to 1, 0 minus 3, 1, 0 minus 3, 2x minus 6, 2x minus 6, 1, 3, x minus 5. And you are allowed to use your calculators, so therefore some students are making very careless mistakes. But you miss points that way, my friends. So what do you get? X times 1 minus x minus 3 is equal to 1 times x minus 5 minus 18 plus 18 minus 0 plus minus 3 6 minus x. So what you get here is x minus x squared plus 3 is equal to x squared minus 5x plus 18 minus 18 plus 3x. This cancels. So you get everything on the right hand side. 2x squared minus 2x minus x minus 3x minus 3 is 0. You have to use the quadratic formula. So x equal to minus b plus minus 2. 3 plus minus square root of b squared minus 4ac. Four to the 8, 3 is 24, 9 plus 24 is 33. There you go, that's the answer. That's the answer. That's very well, that's the answer. And for the row reduction case, this was very simple. I don't understand why people are still not getting it. You are sure to get one such question on the exam 1. I'm spending so much time on chapters 1 and 2. Let me tell you one thing clearly. There's a reason for this. Exam 2 will not cover anything from chapters 1 and 2. The final exam will not cover anything from chapters 1 and 2. The final exam will be exclusively on vector spaces, inner product spaces, and all that. So you must be this, but if you don't know this, then you won't be able to move. 1, 2, minus 3, minus 4, 2, 4, 1, 5, 3, 7, 5, 3. Row reduction. First, interchange the first 2 rows. So you introduce a negative sign, therefore. 1, 2, minus 3, minus 4. 3, 5, minus 2, 6. 2, 4, 1, 5. 3, 7, 5, 3. That's equal to minus 1, 2, minus 3, minus 4, multiplied by minus 3 added to the second row. 0, minus 3, minus 6 plus 5, minus 1, minus 3, minus 3, minus 3, minus 3, 9, minus 2, 7, minus 3, it's 12 plus 6, 18. Multiply the first row by minus 2, add to the third row, 0, 0, that's good news. Is 2, that is 6, plus 1, 7, minus 2, that is 8, plus 5, 13. Multiply the first row by minus 1, minus 3 added to the fourth row. 0, minus 3, no? Minus 6 plus 7, 1, minus 3, 9 plus 5, 14, and 12 plus 3, 15. Okay, so this is so disgusting. Okay, so this is what you get. And now you expand along the first column. So if you do this, then this is the only part that you have to consider. That is minus 1, 7, 18, minus 1 times. So this is 0, 7, 13, 1, 14, 15. Multiply by minus 1, then you get this minus 1, then you get 1, minus 7, minus 18, 0, 7, 13, 1, 14, 15. Okay. Do not disturb, so we are almost done. Minus 7, minus 18. Do not disturb the second row. Multiply first row by minus 1 added to the third row. Minus 1, 7, 21 by minus 1, 18 plus 1, 33. So now expand along this column and you are left with 7, 13, 21, 33. 21, 21 to 31 minus 13, 26, 27, 73. That's the answer. That's the answer. Okay, let me do number 5. Some people, that's the problem where most people got it. Now, number 5, I was a little generous. If I saw the right answer, I didn't mind. But you know, on the exam, actual exam, I will pay careful attention to the method. Correct answer, wrong method will not will get maximum half credit. So it is saying that A is equal to 103 456 456 709 709. B is equal to 200 200 030 030 004 004. Now you have to find the determinant of, you were asked to find the determinant of A squared, B inverse, A to the minus 2, B squared. So this is determinant of A times A, B inverse, A inverse, A inverse, B times B. So, determinant of AB equal to determinant of A times determinant of B. So, remember, so by star, determinant of A, and no, also, if B inverse exists, determinant of B inverse is 1 upon determinant of B. So by star, you get determinant of A, 1 upon determinant of B. 1 upon determinant of A, you must write this. Oh, no space. I hate to teach on using iPad. I absolutely hate it. Determinant of A, 1 upon determinant of B, 1 upon determinant of A, 1 upon determinant of A, determinant of B, determinant of B. So this cancels. This cancels. And you are simply left with determinant of B. Well, that's very easy. What is the determinant of B? You expand along this column. 2 times 12. That is so that was the quiz. That was the quiz. Now wait, I want to ask some questions because I observed some people. Okay, I have to ask this question. Abu Bakr Akhtar, I got your email. You will talk to me. That's fine. Stephen Dorville. Anybody in this class, Stephen Dorville? Stephen Dorville? So Stephen Dorville is not in class. This is very strange because some people didn't take the exam. Samuel Huang? Well, I'm here. What do you mean you are here? What happened? Why didn't you take the exam? Samuel Huang, you didn't take the quiz. And that's what I mean. You didn't take the quiz. Oh, okay, So you didn't take the quiz. Okay, you didn't take the quiz. Okay, you missed quiz. Wasif Khan. So Samuel Huang, you didn't take the quiz. Wasif Khan. Okay, Ariel Moskowitz.
Yeah.
I even wrote you an email, by the way.
Yeah, I'll talk to you after class about what happened.
Okay. Eddie Santos. Eddie Santos?
Are you taking attendance, Professor?
No, I'm not taking attendance. I'm just taking, these are the students who didn't take the quiz. So, okay, no, I'm not taking attendance. Attendance, no need to take attendance now. Okay, good. So that's enough. So I will talk to 2 students after class. Very good. Now, today, so there are only a couple of topics left. Today I want to brush up. I want to go back to, so now I can share. Okay, now I want to go back to what we were doing. Linear algebra. Shania Khan, what are you asking? What's your question?
Professor, I was trying to see my grades, but I wasn't sure. So
No, I sent you the grades. I sent everybody by email the quiz results, and including yourself.
okay, let me check. Thank you.
You must check it. And they were sent last night.
Oh, okay, that makes sense.
Yeah. Graded quiz result. I have the scores here. Okay. Oh, no. Yeah, I want to quickly tell you about this. I did talk about that, but on the first exam, I'm going to ask you questions on orthogonal matrices. So who will remind me of the definition of an orthogonal matrix? Nobody wants to remind me? Of course it is a square matrix, yes. So it has to be a square matrix, but that's not the point. Yeah. Here it is. So you take this as the definition first. Important discussion here. This is orthogonal matrices. Definition. A square matrix A is called orthogonal
If A inverse equal to A transpose?
good if A inverse equal to A transpose. That means A is invertible. That means the whole point is it has to have an inverse. So it has to be invertible. Then equivalently, so you see, if A inverse equal to A transpose, that implies and is implied by A inverse is A transpose. That implies and is implied by A transpose is the identity matrix. So if I give you a matrix, I will definitely ask you questions on orthogonal matrices on the first exam. Here is a matrix A, 3 by 7, 2 by 7, 6 upon 7, minus 6 upon 7, 3 by 7, 2 by 7, 2 upon 7, 6 upon 7, minus 3 by 7. Suppose I give you this Is A orthogonal? That's the question. Is A orthogonal? Well, I mean, there are two ways, right? You have to find the inverse. So you can find the inverse and then the transpose. You have to do both. So you can do both, but why don't we do this? Why don't we just find A transpose? So you have A transpose. I just do this. I will simply multiply that. 3 upon 7, 2 upon 7, 6 upon 7, minus 6 upon 7, 3 upon 7, 2 upon 7, 2 upon 7, 6 upon 7, minus 3 upon 7, times 3 upon 7, minus 6 upon 7, 2 upon 7. 2 upon 7, 3 upon 7, 6 upon 7. Okay, so that is 3009 plus 4 plus 36. 9 plus 4 plus 36, 49 upon 7. 49 upon 49, 0. Actually, you can just multiply and check. So that's 0. That times this. Then this times that. Minus 18 upon 49, minus 18 plus 6 plus 12. Yeah, so that is 0. You can just check. 0, 1, 0, 0, 0, 1. So IA is orthogonal. So if you want to test whether a matrix is orthogonal, you can always do two things. So here is a very interesting, important example, and at some point, much later towards the course, I will come back to this example. It looks so simple, but it has a beautiful geometric meaning. Now here it is, we can easily find the transpose and A inverse. What is A inverse? The determinant is 1, cosine squared plus sine squared, that's 1. So you simply cosine theta, and minus sine theta minus and sine theta. And you see, this is precisely the A transpose. A transpose is cosine theta minus sine theta, sine theta, cosine theta. So A inverse is equal to A transpose, and so A is orthogonal. This is the rotation matrix. You will see that. So couple of important properties. So you can call it a theorem. Part A. The transpose of an orthogonal matrix is orthogonal. Aha, how will you prove that? Prove. There will be some proofs, one or two proofs on the first exam, by the way. Two proofs, maybe. Transpose of an orthogonal matrix is orthogonal. How will you prove that? So, suppose A is orthogonal. Then A transpose is A inverse. I want to prove A transpose is orthogonal. Okay. Now, A transpose is A. So that implies if I take the inverse on both sides, then it is A transpose inverse is A. And that is A transpose inverse, which I just proved. Hence, A transpose is orthogonal. Proved. Part B. The inverse of an orthogonal matrix is orthogonal. The inverse of an orthogonal matrix is orthogonal. Okay, so suppose proof. Suppose A is orthogonal. You'd prove A inverse is orthogonal. So then A transpose is A inverse. Okay, so now A inverse transpose, we proved that long ago, A inverse transpose is A transpose inverse. But A transpose is A inverse. A inverse transpose, A inverse. Okay, so that is A transpose is A inverse, A inverse inverse. And that hence A inverse is orthogonal. You can see that A inverse transpose is A inverse inverse. Transpose of A inverse equal to inverse of A inverse, right? Part C, a product of orthogonal matrices, a product of orthogonal matrices is orthogonal. Okay, so proof. Suppose A and B are orthogonal. Product of orthogonal matrices. No? So AB transpose. So no, okay. So since they are both orthogonal, so A transpose is A inverse and B transpose is B inverse. Okay, now let's start. So AB transpose, I want to show that AB transpose is AB inverse. So AB transpose we know is B transpose A transpose. But B transpose is B inverse. A transpose is A inverse. And that is AB inverse. Hence, AB is orthogonal. D. This is interesting. If A is orthogonal, then determinant of A is, what do you expect, plus minus 1. Proof A is orthogonal. That means A transpose is A inverse. Okay. How will you prove this? That implies A transpose is A inverse, and that is the identity matrix. That implies determinant of A transpose is determinant of I, and that is 1. That is determinant of A transpose. I told you the determinant of determinant of AB equal to determinant of A times determinant of B. But you remember the determinant of A transpose is determinant of A. That implies determinant of A times determinant of A is 1, because determinant of A is equal to determinant of A transpose. So determinant of A squared is 1, and that does it. That implies determinant of A is equal to plus minus 1. Good. So we learned some very important basic properties of orthogonal matrices. Fundamental properties, okay. We will come back to this topic later. But here is my question. I will ask you, I will give you a matrix, I will ask you, is this orthogonal? Of course, that is one question. Here's my thing.
So, Professor, so if the determinant of A equal to plus or minus 1, we can deduct that A is orthogonal?
No. Good question. No. Converse is not necessarily true. Okay. Here's the problem. Find the values of AB. Do it. Let's see.
I already did it in class.
I did it in class?
Yes.
Are you sure I did it in class? Okay, very good. I'm happy to know that I did it in class, but now you do it without seeing what I did. Do it without seeing what I did. Do not see what I did. Okay, good. She's saying that I did it in class, which is interesting. Very good. Good to know that. What is. Okay, why don't we do this? I don't know how I did it in class, but I'm going to do it this way. Now I will ask you what is A transpose. A plus B squared minus plus B minus A squared. So A plus B squared plus B minus A squared. What do you get? A plus B squared plus B minus A squared. So twice A squared plus B squared, isn't it?
Yes, that's
A
correct.
squared minus B squared plus B squared minus A squared. This is 0. A squared minus B squared plus B squared minus A squared. This is 0. And then A minus B squared plus A plus B squared. Then this is 2A squared plus B squared. So wow. So that means, so that should be, for orthogonality, that should be 0, 1, 0, 0, 1. So 2 times A squared plus B squared is 1. So the relationship, find the values. Is that the question? Find the values? So A squared plus B squared equal to 1. So is half. So all values of A and B that satisfy this. Of course, there are infinitely many values. How about this one? I hope, I don't know whether I did this, but this is important. On the first exam, the problem that I will give you is this. Determine whether the following matrix is orthogonal. So you must show the steps. Find the values of A, B, C. Determine whether the following matrix is orthogonal. Show all your steps. Show your steps. Find the values of A, B, C such that the matrix A is orthogonal. And I may ask one of the proofs. Find all values, and the question is, are the values unique? Are the values unique? Do it, let's see. The most important question is, are the values of A and B unique? Okay, then there is another topic, simple, it's very simple, which I want to push now.
Equation.
Ah. Let's quickly finish it, come on. Yeah? Any question? So better not to go for determinant. It's better to do it this way. A is A, B, C, 1 upon root 2, 1 upon root 6, 1 upon root 3, minus 1 upon root 2, 1 upon root 6, 1 upon root 3. A transpose is A 1 upon root 2 minus 1 upon root 2, B 1 upon root 6 minus 1 upon root 6, C 1 upon root 3, 1 upon root 3. Okay, now what is A transpose? A transpose is equal to, let's do it very carefully here, A squared plus half minus, A squared plus half minus half. So A squared. Okay? No, A squared plus half plus 1.
Yes.
AB plus minus, so simply AB. AC plus minus AC. Now let's see. AB, now I'm doing here. AB plus minus, so this is AB. Wow. B squared, B squared plus 1 upon 6 plus 1 upon 6 plus 1 upon 3, isn't it? BC plus 1 upon 18 plus 1 upon 18. So plus 2 upon 18 plus 1 upon 9. Wow, this seems to be quite interesting. Maybe I should have put this on the exam. I missed this. AC, that's okay. BC, BC, BC plus 1 upon 18 plus 1 upon 18. Plus 1 upon 9. And then C squared plus 1 upon 3 plus 1 upon 3 plus 2 upon 3. Oh my goodness. No, 1 upon 3 plus 1 upon 3 plus 2 upon 3. I definitely made some mistake here. You see, it's very nice to make mistakes. B squared, no, I'm right. 1 upon 6 plus 1 upon 6. Yes, I was right. Then let me check this. C squared plus 1 upon 3 plus 1 upon 3. Yeah, this is right. Any questions so far? Okay, so this is equal to 1 0 0 0 1 0 0 0 1. So here you see what you are getting. A squared plus 1 is 1. And that immediately tells you A squared must be 0. That tells you A is 0. So B is 0 because AB is 0. Oh no, B can be anything. I see. B can be anything. No, not B can be anything. B squared plus 1/3 is 1. So B squared is 2/3. So B is plus minus square root of 2 by 3. C squared plus 2/3 is 1. So C squared is 1/3. So C is plus minus 1 over root 3. So yeah, they are unique. A is 0. B, oh my goodness, I'm very sorry. This I should have put on the exam. I missed it. This was a typical exam problem. Don't you think so?
Yes, I can put it on exam 1.
Yeah, exam 1. Okay, that's enough about orthogonal matrices. I want to now show you something. No, not put the same question. Oh, very nice suggestion. I want to show you something. You see, I told you what is a diagonal matrix. A square matrix is diagonal. Let us talk about 3 by 3 matrix. So A is like this. So lambda 1 0 dot 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 all 0 0 lambda 1. Oh no, well, yeah, lambda 2. It doesn't have to be 0 dot 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 0 dot 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 lambda n. All the diagonal entries are there. That's it. Now the question is, suppose I give you a matrix under what condition can I make it diagonalizable? Now, what's the question of diagonalizable? There's a deep theory here. We cannot run away from the theory. We have to come back to the theory, not now, after your second exam. Eigenvalue thoroughly. But now I'm going to show you a purely mechanical method of how to diagonalize a matrix. What's the meaning of diagonalization of a matrix? So, definition. Take this very seriously because I'm going to ask you one question on this. Definition. A square matrix A, we have really started studying the subject now, is said to be diagonalizable, said to be diagonalizable. If there exists an invertible matrix Shania Khan, there's too much noise there. Invertible matrix P. If there's an invertible matrix P such that P inverse AP is a diagonal matrix. Is a diagonal. In this case, if this happens, it is not true that it is not that it will always happen. I will give you the necessary and sufficient condition later under which it will happen. In this case, the matrix P is said to diagonalize, A. So the question that I will ask will be like this. Very, very element. I will give you a 3x3 matrix. And I will ask you to find P that diagonalizes the matrix. So example. Find, and there may be many matrices. One matrix will be enough. Find a matrix P that diagonalizes my goal for theorem for exam 1 is to put all the computational parts as much as, so that on exam 2 and final exam there will be more. There will be, it will be 60-40, 60% computational, 40% proving. Find a matrix P that diagonalizes a matrix, the matrix A. Where I will give you a 2x2 matrix, 3x3 matrix. All right. Okay. Now, here's the method. Here is the method. Step 1 is what we call find the eigenvalues. We will spend a lot of time. This is a beautiful topic, by the way. Step 1, find the eigenvalues. Now, what the hell is this? Find the eigenvalues. What does this mean? It means this. It means this. Eigenvalues are the solutions of determinant of A minus lambda I is 0. Remember, lambda is a scalar, I is the identity matrix. So what is this? This is called the characteristic polynomial, A minus lambda I. Don't worry about that. So what is A minus lambda I in our case? It is 0, 0, minus 2, 1, 2, 1, 1, 0, 3, minus lambda, 1, 0, 0. It's a 3 by 3 matrix. So this guy is A is a 3 by 3 matrix. So the identity matrix has to be 3 by 3, 0, 1, 0, 0, 0, 1. So that is what? That is 0 minus lambda, 0, minus 2, 1, 2 minus lambda, 1, 1, 0, 3 minus lambda. That is your matrix. So when I say determinant of A minus lambda I is 0, what do I mean? I mean determinant of this matrix is 0. That means minus lambda times 2 minus lambda times 3 minus lambda plus 0 plus minus plus minus 2 times 0 minus 2 minus lambda is 0. Okay, so that gives me what? That gives me minus lambda, 2 minus lambda, 3 minus lambda, minus 2, 2 minus, no, plus 2, minus minus plus 2 minus lambda is 0. So that is, take 2 minus lambda common, 2 minus lambda, and then you have 2 minus 3 lambda plus lambda squared is 0. So 2 minus lambda, lambda minus 2, lambda minus 3, minus 1 is 0. So that immediately tells you that there are two values, lambda equal to 2 and lambda equal to 1. These are called the eigenvalues. These are called the eigenvalues. The eigenvalues are lambda equal to 2, lambda equal to 1. So remember, the determinant of A minus lambda I is called the characteristic polynomial. But we don't care for that, but just name. But I've got my step 1. Now what you do is step 2. Consider wait. How will I do that? Wait. Yeah, very good. You don't need all that rubbish. AX is 0. Exactly, lambda, good. Should I put that? Okay. Consider this matrix. A minus lambda I, now this is going to be a matrix, times X is 0. X is where? X is These will be called the eigenvectors. We will talk about them later, not now. And this is a zero matrix, remember. This is the zero matrix, otherwise it makes no sense, right? Consider the matrix equation. So you don't get confused. Zero matrix. What does this mean? That is, what is A minus lambda I? I just got that here. Here it is. Minus lambda 0 minus 2. 0 minus 2. 1, 2 minus lambda 1. 1, 2 minus lambda 1. 1, 0, 3 minus lambda. 1, 0, 3 minus lambda. This is my A minus lambda I. x1, x2, x3. I'm interested in x1, x2, x3. Okay? Here is the name of the game. You see, I've got two values so far. I have got two values, lambda equal to 2, lambda equal to 1. So for lambda equal to 2, if I put lambda equal to 2 here, what do I get? Minus 2, 0, minus 2. 1, 0, 1. 1, 0, 1. And I want to find the basic values of the, I will understand what I mean by basic values. See, so minus 2x1, just do the usual multiplication, plus 0, so minus 2x3 is 0. You are not going to get unique values, you will see that. Plus x3 is 0. x1 plus x3 is 0. That's what you get. Aha! So you see, here's the catch. Look, listen guys, this is beautiful. Here's the catch. From these three equations I get x3 equal to minus x1. And no control on x2, right? Naturally, no control on x2. So the solution will be like this. x1 is anything, x2 is anything, but x3 is minus x1. So what you write is, so this x1, x2, x3 becomes like this. x1, so it becomes like this. x1, x2 minus x1. So, how will I write this vector? This is a column vector. How am I going to write this vector? You see, here is the trick, very important, interesting trick here. You see, I have no, x1 can be anything, x2 can be anything. So here is the magic trick. Look at what I'm doing. x1 times column vector 1, 0, minus 1 plus x2 times 0, 1, 0. My friends, please take a look at these two column matrices. So this is the situation when lambda is 2. Let us now consider, there are two values we found, right? Lambda equal to 2 and the other one is lambda equal to 1. Very easy, now you're getting it. For lambda equal to 1, what happens? Let's go there. Lambda equal to 1. So minus 1, 0, minus 2. Minus 1, 0, minus 2. This is the problem of doing things with iPad. 1, lambda equal to 1. 1, 1, 1. 1, 1, 1. Lambda equal to 1, 1, 0, 2, 1, 0, 2. x1, x2, x3. This is standard, this cannot change. And now tell me what you get. Minus x1 minus 2x3 is 0. x1 plus x2 plus x3 is 0. x1 plus 2x3 is 0. Aha! So from here, I get something interesting. What I get is x1 plus 2x3 is 0. That means x3 is minus x1 upon 2. Or x1 equal to minus 2x3. Go to second equation, you put minus 2x3. So minus 2x3 plus x2 plus x3 is 0. So x2 minus x3 is 0. So x2 is x3. So what happens to this guy here? x1 is minus 2x3. So x3 remains as it is. x2 is x3. x1 is minus 2x3. So x3 is any value. Minus 2, 1, 1. Take a look at this now. This is one column matrix, and another column matrix. So my question was, how do I find that says that P inverse AP is diagonal. So my question is, what is P? Find the matrix P. That is the original problem. And you see how mechanical this is. The matrix P is, you can close your eyes and write it now. You see, you got these two, 1, 2, first column, second column, third column. 1, 0, minus 1, 1, 0, minus 1. 0, 1, 0, 0, 1, 0, minus 2, 1, 1. There you go. You want to try? And this is not, I won't ask you that, but see, the question was P inverse AP is diagonal. So the answer is P, that's it. But just check. You don't have to do this on the exam. Just because you're learning now, P inverse AP, I want to convince you that P inverse AP is diagonal. So let us take a look at P, how to find P inverse. So what is the determinant of P? It should be easy because the numbers are easy. 1 times 1, 1 plus minus plus, oh my goodness, so that is very easy. And now you get the matrix of cofactors, plus, minus, plus, minus, plus, minus, plus, minus, plus. So the matrix of cofactors will be 1, minus 1, negative 1, one. Zero, this is 1 minus 2, that is minus 1. 0. Minus 2, 2. 1, So then this is the matrix of cofactors. So adjoint will be 1 minus 1, 1, 0 minus 1, 0, 2 minus 1, 1. And what is there for P inverse? Determinant is minus 1. Just change the signs, that's all. So what is P inverse A? P inverse is A. Where is my A? Right at the beginning I had my A. Where is A? 0, 0 minus 2, 0. This is so disgusting. 0, 0 minus 2. Where is A? Yeah, I can do it this way. 0, 0 minus 2, minus 2, 1, 2, 1, 1, 0, 3. So, zero, 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 1 plus 1, 2, 0, 0, minus 1, 0, 0, 0, 0, 2, 0, 0, 0, 2, minus 3, 2, minus 6, minus 4, minus 2, minus 2 plus 1, minus 1 plus 3, minus 1 plus 3, 2, 2, minus 3, minus 1. So P inverse A, P will be what? I hope we didn't make multiplication mistakes. Then we will be in problem. You don't have to do this because I'm just showing you that what is your P. P was what? Okay, well, so forget about this. Let me copy from here. P was what? 1, 0, minus 2. 1, 0, minus 2. 0, 1, 1. 0, 1, 1. Minus 1, 0, 1. Minus 1, 0, 1. Minus 1, 0, 1. Now let's see whether we did things correctly. 2, minus 2 plus z plus minus 2 plus 0 plus 4. Minus 2 plus 4. 2. 0. Oh, shoot. No, that's okay, that's okay. That's okay. 2 minus 2, 0, very good. Minus 1 plus 1, 0, very good. Very good. Okay, minus 2, 0, 0, good. So 2, 2, this is 2. And then 0, 0, 0, very good, it's coming up right. 4, 0, minus 4, 0. Minus 2, minus 4 plus 2, plus 2. Minus 4 plus 2 plus 2, 0, 2. Oh my goodness, this is a beautiful answer. Now, there is 2, 2 plus 0 minus 1. So this is 2 plus 0 minus 1. So this is 1. So here's the diagonal. Yeah, this is diagonal. This is the only, that's the diagonal. Diagonal matrix means you will have only, so you don't have to do this. Your actual problem finishes here. Yeah. That's where your problem ends. We will do some practice. So let me write down here a very simple question on orthogonal matrix I will give you. Can you give us home? Yeah. I will give you homework. I will give you practice. Exam 1, 1 to 2 plus diagonalizing matrices. Diagonalizing. Only a 3 by 3. The review will be so this will be a good exam then. So then, because this is something that I want to finish. This is just very mechanical. So you don't know. All you need to do is just find the matrix P. You don't have to find P inverse AP. No, nothing. All you need to do is to just find the matrix P. That's it. Nothing else. Okay. So or by the way, wait, let me ask you this question. Will you agree? Okay, wait. Because this may be, I will give you a little more than an hour, 1 hour, 15 minutes, and there will be many other topics. Okay, just let me reduce this so that things can be manageable for you. Because, okay, I won't ask you to diagonalize matrix for exam 1. For exam 2, I will ask you. Here I will ask plus finding eigenvalues. That is good. Now everybody will like it. Let's do one more. Now this everybody will like. And this you can easily finish. So let us take eigenvalues, then on exam 2 eigenvectors, then on final exam diagonalizing. How about that? So this you will really like. So here is something like this. This is how the question will come. Find the characteristic equation. Find the eigenvalues of the matrix. Say, let's take something like this. A. 1 minus 3, 3. 3 minus 5, 3. 6 minus 6, 4. So what is it that I'm saying about eigenvalues? Remember, the eigenvalues are the solutions of the characteristic equation. This is called characteristic equation. And what is the characteristic equation? Determinant A minus lambda I is 0. Good. Yeah. So exam 1, eigenvalues. Exam 2, eigenvalues and eigenvectors. Final exam, how to diagonalize the matrix. No, exam 1, eigenvalues. Exam 2, how to diagonalize matrix. So no diagonalization for exam 1. Just this. So this is very routine. So A minus lambda I is what? 1 minus 3 3. 3 minus 5, 3. 6 minus 6, 4. Minus lambda. 1 0 0 0 1 0 0 0 1. So that's my A minus lambda, lambda I. So that is 1 minus lambda minus 3, C minus 0, 3. 3. 5 minus lambda. 3. 6 minus 6. 4 minus lambda. So determinant of A minus lambda I is 0 implies what? Determinant of this is 0. This determinant is 0. So now just solve this. So let's see. So this is 1 minus lambda times minus 5 plus lambda, 4 minus lambda, minus 18 plus 18, plus minus plus 3, minus 18, minus 6 times minus, so plus 5 plus lambda. Plus minus plus 3. I made a mistake. No, I made a mistake. Yeah, I made a mistake. I did make a mistake. 3 times, no, sorry. It's easy to make mistakes here. This goes away. 3 times 4 minus lambda minus 18. Very good. Plus 3, now I'm okay. Minus 18 minus 6 minus plus 6, 5 plus lambda. 0. Now that's very routine algebra, so let's do this. So that is 1 minus lambda minus 20, 4 lambda minus 5 lambda minus lambda squared plus 18 plus 3, 12 minus 3 lambda minus 18 plus 3 minus 18 plus 30 plus 6 lambda. So 1 minus lambda squared plus lambda minus 20 plus 18 minus 2 plus 3 minus 3 lambda minus 6 plus 3 6 lambda minus 18 12 is 0. Okay, so what are you getting from here? I hope I'm getting a common factor, isn't it? So 1 minus lambda minus plus 2 times lambda minus 1. And over here, this is plus 6 lambda plus 12. So minus, take 3 common, 9 lambda plus 2. You can see what's happening. Plus 18, take 6 common, lambda plus 2. That's exactly what I wanted. So lambda plus 2 times. So now you're also, you can just do it. Minus lambda minus 1 squared minus 9 plus 18 is 0. So lambda plus 2 minus lambda squared minus 2 lambda plus 1 plus plus 9 is 0, lambda plus 2 minus lambda squared plus 2 lambda minus 1 plus 9 is 0, lambda plus 2, take minus out, lambda squared minus 2 lambda plus 8 minus 8 is 0. So lambda plus 2, lambda minus 4 times lambda plus 2 is 0. So you get the eigenvalues are lambda is minus 2, lambda is 4. This is the kind of question I will ask you. Just find the eigenvalues. So I'm giving you homework. So eigenvalues, just calculating eigenvalues, I've written here. Eigenvalues. So 2 by 2 or 3 by 3. Not more than that. No need to go beyond that. Homework. Find the eigenvalues of the following matrices. Number 1. Let me give you a minus 2, minus 7, 1, 2. Number 2, 1, 2, minus 2, minus 1. 4, 0, 1, minus 2, 1, 0, minus 2, 0, 1. 6, 3, minus 8, 0, minus 2, 0, 1, 0, minus 3. 4, 0, minus 1, 0, 3, 0, 1, 0, 2. Okay, so Tuesday I will be doing some, I'll have to do some Gauss-Jordan elimination, some row reduction. I will quickly do those things and then we will discuss this problem. Try this promise. This is your homework. Okay? Okay, that's the end of today's discussion. I need to talk to, yeah, so I'm ending the meeting now. Here are your practice problems. I've made it very simple, just the eigenvalues for exam 1. So laying the foundation for what is coming. Good. Okay, any questions, anybody? Good, see you on Tuesday. Okay, I just want to, yeah, there are 2 students who will talk to me. Everybody can leave now, except